on.
Here we go.
We are live. Yay, Sean says we are on. Finally. Took 5 extra minutes and some engineering effort, but we figured it out. Hi, everyone. Thanks for joining the stream. Sorry for the delay. We don't do this often enough, obviously. So we had a bit of a mess up with our setup, but we are live. So welcome. Let's just give maybe a couple more seconds for people to join. And in the meantime, I guess, as you know, we will be talking about GraalVM for JDK 22 today. So feel free to guess in the comments what will be the new features or suggest what you would like to see in GraalVM for JDK 22. Hi,
Hey,
Dan.
Matthias. Yeah, hi, Dan. Good to see you here.
Okay, I see a few people more are joining, but I guess we can begin because we've been delayed anyway. And today we have a special setup because we need to finish exactly on time. We have only 1 hour and actually less because if you know at what will be 6 p.m., I guess, Central European time, also the Java release stream will go live. And we want to see that stream and we want to give you a chance to see that stream as well. So today we have less than 1 hour. So yeah, we can just, I guess, begin. So hi everyone again. My name is Alina. I'm a developer advocate for GraalVM.
Hey, and I'm Fabio. I'm a researcher on the GraalVM team. And yeah, good to see lots of familiar faces and new ones as well. Hello, Wolfgang.
Yeah, we see some people from the team, some people from the community. It's great to see everyone again.
Yes.
Okay, so let's get into it. Let me share my screen. So as you know, or as you might have guessed, we are talking about GraalVM for JDK 22 today, and we have some exciting updates to share with you. But all of this, all the things that we will show you today are already live. So the release blog post, the downloads, the release notes, everything is already available. If you want to look at those things together with us, you can also go to our website, graalvm.org, and there you can get the links to everything, to the release notes, but actually you can already download GraalVM. One more comment here that SDK man, we left a comment here saying coming soon because there is some time that is needed to propagate and be available on SDK man. But we saw a tweet from the SDK man folks today saying that GraalVM and Java builds are scheduled to go live and be available on SDK man tomorrow morning, I think. So they should be available really soon. Okay, Fabio, should we talk about what's new in this release?
Yes, maybe zoom in a little bit.
Yeah, good call, because Medium has this thing where it gives you a very narrow kind of article view. So yes, welcome GraalVM for JDK 22. It's being released today. As you know, on the same date as Oracle JDK and OpenJDK is being released. We are aligning with Oracle JDK, with OpenJDK, and part of that aligning is that we are releasing on the same day, so you can get access to the latest Java features and the latest GraalVM features all in one place. And actually, we have this very cool table here showing which of the features of Java 22 are already available on GraalVM, on Jet, and in native image.
Yeah, and generally the good news is that, as you can see from this high level, maybe Alina can also zoom in a little bit.
Yeah.
Most of it is actually available. Some parts, or just one part, is partially working, namely Panama on native, but it's working fine with the GraalJIT. Vector API is working. Well, there are still some optimizations pending that we're working on in the GraalJIT. So if you're benchmarking with the GraalJIT, maybe take your results with a grain of salt. In native, we're still working on it, on support for it. And we also carried over a JEP from JDK 21, generational ZGC, which is still not working with the GraalJIT, but the team is working on this. And in native, it's not applicable because there's no ZGC available in native image at the moment.
Yep. And Fabio mentioned an interesting thing about benchmarking. So you might have seen an announcement that we now have early access builds available also for Oracle GraalVM. And what happened, we are releasing GraalVM for JDK 22 today, but already yesterday we saw some community members benchmarking GraalVM for JDK 22 because they just took early access builds, and as we are releasing those builds, they already benchmark them and share the results publicly. So even before we release kind of production grade version of GraalVM for JDK 22, you can already try it out with the early access builds.
Right, and from what I've heard from the SDK main team, GraalVM early access build should also become available in SDK main very soon. So it will be really easy to just do, I don't know, 23 EA GraalVM or something to get your hands on an EA build if you really want to test on the latest and greatest EA build. But today we're here to talk about JDK 22 features and the release, right? So why don't we go ahead. Yes, you can download the binaries already, and Alina has already showed you the download page. The release notes have more details, so you can go through the notable changes in this release. And there's also a second blog post on truffles and GraalVM languages. So if you came here to learn more about truffle stuff, maybe you want to read that other blog post. But also maybe we do a follow up stream just on the truffle bits. And here we're just focusing on the Java and JDK updates.
Yep.
Alina, 1 billion row challenge.
But I think we wanted to demo first, right? So we talked about all the cool features in GraalVM for JDK 22. Maybe we want to show first a demo, and
Right.
then we can talk about the 1 billion rows challenge. So we brought this fun little demo. This is based on LangChain4j. Let us know in the comments if you like that project, if you have tried building something with it already. So what we want to do here, we want to use an LLM and give it an input from a user. So we will be the user in this case. And we want this open AI model give us the output of that user input. So basically, it's a tiny little, let's say, CLI chatbot that is using OpenAI to give you questions to your answers or comment on your prompt. So let's give it a try. And this is built using, as I said, LangChain4j, but also plain GraalVM. So this is not using any framework at the moment, just GraalVM, and that is based on Java 22, but don't take my word for it. Let's verify it. So if I run this, indeed, we see that this is running on Java 22 Oracle GraalVM. So let's run this app. And to run, I have this little script here, just so I don't need to type that much. So let's run it and let's ask it some question. So let's run it and maybe let's ask it what it thinks of GraalVM. So what is GraalVM?
So this is using the ChatGPT 4 model, I think. I've just seen it in the
as far as my LangChain4j knowledge goes, it is using GPT-4.
Yeah.
So it says that GraalVM is a high-performance runtime that provides significant improvements in application performance and efficiency. Keeps going, but seems like a legit answer to me. Yep, we can ask it something else. I don't know, Fabio, if you have any ideas.
Yeah, what is Java? Might be interesting.
Yeah, let's see. What is
what
Java?
The model has learned.
Java is a high-level, class-based, object-oriented programming language that is designed to have as few implementation dependencies as possible, I guess. Okay. Originally developed by James Gosling at Sun Microsystems and then becoming part of Oracle. Okay, sounds fair enough. But this is running on JIT, and obviously we are here to talk about GraalVM, and we love native image. So let's see if we can build it as native image. And I will run the command, and then I will tell you what exactly it does. So build native. And let's look at the script. The script that I'm using to build my application as a native image is here. And Fabio raised a good point when we were talking about this demo before, that here I'm just doing native image -jar, passing my jar, and then just customizing that I want to have a different name for my binary. And Fabio said that it looks exactly as the Java command, right? Because that's our intention, that with native image, you have as close experience to the JVM experience. So you can just drop in, replace Java with native image command. And then our goal is that you can use all the same flags, all the same commands as much as possible to build native images as you would run on the JVM.
Yeah, flags like -jar or -class path, CP module path or -m, Java -m, JDK Git.http server is our favorite little simple web server and the simplest app that you can build. And all you have to do is replace Java, the Java launcher, with a native image launcher, and then it should just build the executable. And when you run the executable, you get the result. And right now, this is building on your machine, right?
Yeah, oh,
And
good point. This is running on my local machine and building on my local machine, which I'm also using like for streaming and everything else. So take it with a grain of salt that it's taken some time to build because this is all running locally and there's tons of heavy stuff running on this machine.
yeah, but it seems like it finished in a minute and 12 seconds, which I
Yes,
think is pretty good
but it's everything
considering.
on. Yeah,
Yeah, it analyzed the whole JDK, including your application with all its dependencies. I'm guessing, even though this is calling out to OpenAI, it's still there's still some dependencies for this
but
application,
for
and all
quite a
of this
few.
is turned into an executable, and looks like it's 44 megabytes in size.
Yeah,
Cool.
looks quite nice. So let's take it for a spin. Let's do native Lang4j. Actually, you can also suggest questions to the model in the chat, but be nice. So if you can come up with a question, we can also ask model that. But let's do something else. I don't know. Tell a programming joke. Okay, this can go many different ways, but let's see.
Maybe we should have done the original question as well. Unfortunately, your name is right above the answer, but so we
Oh,
can't see the answer, which is
oh,
good.
let me, good
Yes.
point. Let me move this
Yeah.
higher.
So why don't programmers like nature? What's
It
the
has
answer?
too many bugs.
That joke.
Yes. I mean,
Okay.
we are also getting a question in the chat as saying that looks like the memory usage during compilation has improved.
Yes,
Uh,
that is something that we keep tweaking. So if
yeah.
you can scroll up in the build output.
I mean, we also see
Um,
Picker says here, right?
Yeah, but can you scroll up to the very
Yeah.
beginning? So this is there's a new section called the build resources section, the yellow bit, and it tells you what is available to native image. So what it found available on your system in terms of memory and whatnot. Yes, you can also see the experimental options that Alina has used for this, but that's a different story. So, yeah, the native image build process decided that it can use up to 12 gigabytes of memory on the 16 gigabyte machine, and it's using all of the 8 available processors. And yeah, if you click on one of those words that are underlined, you actually get to the documentation, and they
Yeah,
will
you can
help
see the link,
you.
right?
Yeah, they will tell you exactly how you can change those values if you think you know better than the heuristic, or if the heuristic doesn't work for you as well. But it's designed to work for most users, and generally, yes, we keep reducing the overhead. So on the right hand side, you can see how much memory is used by the Java process building the executable, and it's around 2 gigabytes. And if you scroll down, as you already shown,
Yeah.
at the peak, it used 2.7 gigabytes, which is not that much. So we've tweaked the native image builder a lot to keep the memory consumption low, and also the heuristic is pretty good. So if you have an IDE open, which is quite common as a developer, then it won't mess with your computer too much. But if you are running on a dedicated machine, then it will try to use as much as possible as well. So yeah, that's a cool new update in this release.
Yeah, we keep working on developer experience so it gets better with every release. So yeah, I think we can move on because we are limited in time today. But I hope this quick little demo shows you that you can use libraries such as Lang4j to build Java applications using
Oh,
LLMs, and then you can easily convert them to native executables.
do we still want to time it though? We can
Oh,
time.
good point.
Yeah,
Yes, let's
yeah.
time it though. We love, measuring things and seeing how faster or not faster we'll see native image will be. So let's time all of this and let's go back to our Java command and let's time it. We want to just do plain time, right?
Yep, plain
Yep.
time is fine.
Granted, there is an API call there, so there could be some fluctuations in terms of time, right? But we want to see how much resources this application is using on the JVM versus on native image.
Yeah.
Uh, can you see? Oh, it's still.
Yeah, can you
Yeah,
move
yeah, yeah. Let
the
me
editor
clear
up a
this.
little bit?
Yep.
Oh, now you just removed everything.
I can run it again though. I mean,
Yes.
it will not warm up that much in one run, hopefully, right? So
Yeah.
let's see.
Yeah, so that's the response that we're getting. And what we see here on the last line, maybe you can highlight it. It
Yeah,
says that the program ran 1.15 seconds in user space on the CPU and zero point zero 0.09 seconds in the kernel space. And that accumulated 20% of CPU usage. And the wall clock time was around 6 seconds. So now you may be thinking 1 plus 0.009
yeah.
is not really 6. Well, that's the time it takes for OpenAI to respond, right? So that's why walk clock time is much higher. But maybe run the native version now with the
Yeah,
same
let's
input.
run the native one and let's time it as well.
Well, use the same input, right? We want the
You
same
think it
input.
makes a difference?
Well, you never know. Maybe we get a different response, and then
I think we will get a different response, but let's see. So we were asking what is Java.
yeah. When you're benchmarking, you don't want to change too many variables at the
I
same
mean,
time,
fair enough. Okay, and maybe we'll
and
get a
change.
different version of what is Java.
Yes. So, yeah, here we go. So, wall clock time has improved 4 seconds, but also user and system time has reduced dramatically, right? We went down from 20% to just 1% CPU usage, which is almost nothing. And that's honestly, that's what you would expect from an application like this, right? It just calls out to an API point on the internet and then prints the result. So I think that's a pretty good result. And
Yeah,
of course, we could now go on and measure instructions, measure peak RSS. But I'm guessing you're familiar with native image. And yes, memory consumption has improved by using going native here. And yeah, the usual benefits like improved security and so forth, they also apply to this binary.
I think when we were also
Okay.
doing our like trial run, we also saw that memory usage was about 3x lower than the JVM, and that is without any tweaking and any limiting from our side. If we wanted to, we could have like improved it even further. But out of the box,
Yes.
memory was like 3x lower than running on the JVM.
Correct.
Okay, should we move on and talk about
Yes.
the 1 billion rows challenge?
Yes.
So
Do it.
you might have heard of this 1 billion rows challenge in the community that was introduced by Gunnar. And the challenge was to take modern Java for a spin and see how fast you can parse and process a 1 billion rows file and build a Java application for it. And his initial solution, so the one provided by Gunnar, was taking for almost 5 minutes to process that file. But then many people jumped in and joined the challenge, and there were many versions. But then the most optimized ones were running as fast as almost 2 seconds on 8 cores, and then even down to zero point 0.3 on all 32 cores available on the machines. But the fun part that I want to show you is this one, where you can see the results, and that's the leaderboard. And you can see how pretty much all of it, almost everyone from those leaders are using GraalVM and namely native image.
Yeah, it turns out even processing 1 billion rows eventually turns into a warm up challenge. And of course, you can only beat that one with native image. Yeah, that's a
Yeah,
pretty good result.
that's a good observation. Yes, and we wanted to quote a few people from the community who also observed a similar thing like Fabio did. And I like this quote from the QuestDB team. So they said that there are many optimizations that you can do to your application, to the way you write it, to the way it does, to what it does. But there is a level like step zero optimizations, and that is choose a good VM. And they said a GraalVM is one fast VM. And of course, we would agree with that statement. And some more fun comments from the community. I like this one saying, like, wondering if 1DRC is actually a secret GraalVM marketing stunt. It wasn't, but we are happy that it made GraalVM act and look so good. So yeah, you can read more about it. There are different articles, podcasts, etc., talking about it in more detail. We just want to share one more observation from our team. So we benchmarked Thomas's, so our lead Thomas with the solution running on JVM versus native image. And while everyone shared observations of how fast the application got the job done, we also wanted to measure the resources usage. And in our observations, it took the JVM version 125 CPU cycles to process a row. so per row, while native image took only 78 CPU cycles to do the exact same task, so to process one row. So fast startup memory usage, that is all great, but we also want to show how native image is way more efficient in terms of resources usage. So if you want to minimize how much resources you're using, if you want to make your apps more green, native image is also the way to go.
Yeah, it simply just means that you can run the same workload with fewer CPU cycles, right, and get to the same result. Right. So, is there anything you want to add to the 1 billion row challenge still, or
No, I think we're good. We can
okay?
move on. Yeah, and we have one more update here that is not from one BRC, but we are talking about performance. We just added one more thing in this release. And yeah, that
Yeah,
is the,
those are concerned with that's for Java records.
yeah.
Yes, those are supported by native image, but we got feedback from the community that they weren't as performant as they could be. And more specifically, if you put Java records, for example, into a hash map, then equals and hash code would be used a lot on those records. And they weren't properly intrinsified, which means that the performance wasn't as good as it can be. We fixed this, so now you can move your from classes to records for the types that you want records for, without seeing a performance reduction. It should just be very fast now, and that's good. And that's another example for like the community, and that we're listening to problems pointed out by the community, and we try to fix them as soon as we can, so that there's no reason that GraalVM holds you up using the latest version of Java and all of its features. The next topic is actually a bit more complicated and specific to native image. So in the JDK 21 release, so the last release, we introduced a flag called strict image heap. And this flag is now turned on by default. And this is actually a good thing. It means, well, previously we were executing class initializers on the JVM that is running the build process, which can cause all kinds of different problems. But now we are actually simulating the class initializers, which is really cool because it allows us to observe exactly what the side effects are. And then we know exactly what is becoming part of the image heap, for example. And what you don't want is you don't want like a password or some other secret to end up accidentally in your executable. So with strict image heap, we now require users to mark every type that actually ends up in the image heap in an executable to be included. And you do this by saying, yeah, this can be initialized at build time, and the error message will actually guide you through the whole experience. So if you see an error message, just read it, follow it, and hopefully it's clear what you need to do. And if you still have a problem, feel free to open a ticket. And if you're curious how all of this works, there's a link to the original GitHub pull request with lots of information, how the simulation works, and why we had to introduce the strict image heap flag.
Thanks, Fabio. And I want to talk about one more feature in this release. So we have native image build reports that show you different information about your build. So what system it was built on, what was included in the image, provides your SBOM, etc. And now build reports also can show the profile information that was collected during the instrumented run of PGO. So now we can visualize those in the form of flame graph. And that can show you where your application effectively spends time in which methods, and also which methods are considered hot by the compiler and where a compiler focuses the efforts. So this one we actually also want to show you a demo for. So some time ago, we published this blog post about PGO and other improvements in PGO. And that in that blog post, there was this game of life demo. And if you're familiar with game of life, it's basically a computation intensive application. So in our case, we have a grid, I believe, of 4K by 4K, where each cell is alive or dead based on its neighbor state and the rules. So long story short, it's a computation intensive application, and we want to produce a flame graph that will visualize the profile information of this app so we can see where this application is spending most of its time. So let's go ahead and let's run it. And it's this one. So to produce the build report and include the flame graph, I will just pass those two flags. And let me just this time not forget to clear all this and maybe move it a bit higher up. So let's run it. And this is relying on the profiles, so the profile information that you collected in advance. So you also need to pass the PGO flag and make sure you actually have the profile information available. In my case, it's over here in the project folder.
Yeah, so last year when we gave a talk at Devox, we got lots of questions regarding PGO, and there will be more good news regarding PGO in the release blog post. But this is just one example of how we want to help developers make sense out of PGO. And while I was talking, it is already finished compiling Game of Life. So 23 seconds, pretty
Yeah,
good.
can you appreciate how fast this was on my not like the strongest machine, and also while streaming and doing everything else? So I think this is pretty cool. But let's open the report and see what's inside. I think it's built. Yes, should be it. And
Yeah,
here
so this essentially gives you the summary of what you've seen in the build output in the console. And you may want to, for example, persist this for every build that you make. So later on, you can come back and like check what this binary consists of, or like how many types were actually reachable. And you can get lots of interesting diagnostics in here. You can
this
drill
is
down on the
pretty
code
cool.
area. Yes, and see what's in the image heap, right? But the new feature that Alina wants to talk about are these PGO sampling profiles, right? And that's the tab.
Yeah, so this is it. This is visualizing basically based on the samples that we collected, where your application spent time in which of those methods. And then it's color coded. So the red ones are hot compilation unit, and then those blue ones are inlined in that hot compilation unit. And then the gray color, that is methods that are considered cold. And it's also kind of interactive. So upon hovering, you can see how many samples have been collected for a particular method. And yeah, you can explore it. It's zoomable. You can go inside each of those, and it even has a search. So if I do, I think F, I believe, I can look for a specific thing. So that was this apply rules method. So if I do it, it will highlight in the flame graph and also in the histogram that it comes with. So this could be helpful if you want to understand which methods of your application contribute to the overall execution time, and also get a better understanding of how the compiler sees your app.
Yes, this essentially has like multiple data sources. It takes the information from the PGO profile, so what you have gathered or what has been recorded when you ran the application on a representative workload. So here you can, for example, see if something is not hot that you would expect to be hot, then your workload may not be the one that you thought it would be, or something is hot that you didn't expect to be hot, and then maybe you want to take a look at those methods because that's usually the interesting bits that you want to tweak first to improve performance. So the other thing that you see here is also the decisions taken by the compiler. So the compiler decides, okay, this is a hot method, so I spend more time optimizing it on it. But he can also see, for example, the top the very top blue things. They're all included in actually one compilation unit, the one down below. So all of the three are actually in this red one. They're all inlined. And there's also some gray ones, for example, and those are not actually inlined, or they're just cold. So this means that like the green stuff has been optimized really, really well, and it's put into other methods to speed things up to avoid function calls, which can be expensive. And there are some gray parts in this application where the compiler said, okay, it's not worth spending too much time according to the profile. Maybe you can click on this. Maybe we can see and learn what's actually inside. So this says something like load grid. Yeah, load grid is probably something that only happens right at the beginning and
Right,
only
makes
once,
sense.
right? So that makes total sense to me.
And this one, I don't know.
Well, that's coming from the JDK, right? So
Yeah,
load grid must be calling char add to
I guess. Yeah.
pass the file and load it. Yeah.
Anyway, looks great. Let us know how you like this feature. I can already tell that Dan says that this looks very handy for developer teams. We think so as well. Let us know how you like it.
Yep.
Yeah, let me just, yep, done. Okay, let's see what else is new in this release. So we talked about visualizing profile information with flame graphs, and Fabio made a good point that we're getting a lot of PGO questions. It happened to us at DevBooks Belgium, but also we are getting a lot of those online. And to address those, we are adding more and more features to PGO. And for example, now we added those two new features. One of them is allowing you print basically profile quality. So in the step 5 of the native image build output, you will now see this new metric showing you two things, that is profile applicability and profile relevance. That will show you how relevant your profiles are to the application, basically let you assess the quality of your profiles across different builds and different runs.
Yeah, and here I'd like to add that if you look at this example here, the numbers for applicability sounds rather low, but please go ahead and read the docs. They hopefully they will help you understand what this really means. It just means that 21% of the samples in the profile apply to hot areas in your application, and what you should be doing is not like freak out that it says 21%, but go and compare, and not while you're not rebuilding your or not re-recording your regenerating your profile, you can make changes to your application, and then this value may decrease over time, right? So it may drop to 21.5%, and then you know your profile has slightly gotten out of date, but eventually maybe it drops below 15, right? And then that's something that where you really want to regenerate your profile, maybe to make sure that it's still up to speed, right? So this is as Alina said, an experimental feature, and we'd like your feedback on it. Hopefully we can find smart ways to make it even more user friendly in the future. But take a look at the docs. The team did a really good job at explaining and providing more explanations to how PGO works in native image and how you can make the most out of it.
Yes, sounds great. And going back to the Java 22 features, we have an exciting update on Project Panama. So we are working actively to make it available on GraalVM. So right now in this release, you can already give it a try. It works, I believe, on x64, yes, in this release. And what is supported is down calls, so calls to the native code, and also, I believe, foreign memory access. So you can already give it a try with this flag for an API support that also requires you unlocking experimental options.
Right.
And talking about more developer experience updates, so now you can also use Oracle GraalVM build pack that helps you more easily adopt GraalVM and Oracle GraalVM for your projects, and specifically also for Spring Boot projects where this kind of setting is actively used.
Yeah, well, we got lots of feedback that Oracle GraalVM is very interesting for many projects because of the new license. You can use it for free in production, right? And Spring actually builds through Buildpack by default. And now there's an easy way to just go and use Oracle GraalVM to squeeze out additional performance, or to use more advanced features like SBOM or G1GC, right? And the instructions for Maven are just shown here, but there's also a blog post just on this with more instructions how to use this in Gradle. And I think Quarkus also has support for build packs where you can use this as well.
Right. And we keep talking about developer experience because we care about it a lot. So there are also a bunch of small changes in this release specifically for developer experience on native image. So one is that working with reflection got easier, and now more methods and fields and constructors are discovered automatically by native image out of the box without any help from your side. We also have added support for the native image options environment variable, which I think is Fabio's favorite.
Well, it's certainly very convenient. You can now set an environment variable and pass in additional bit flags. So why is that useful? Because, for example, you can add this to your bash or zsh config, and then always turn on quick build mode, for example. That's what the example underneath show you how to do. Don't forget to prepend any previous native image options, so otherwise you would overwrite them. And if you use this, you will see what's actually been injected into the build in the build output. It will tell you it has picked up the -OB flag in this case, right? Just like the Java tool options flag does when you run it on the JVM. And yeah, that's actually not just one of my favorite features, but it's been requested by the community for quite some time, and we finally had the time to properly implement this. I think we just got the first question. When can we expect parallel GC to be included in Graal? Well, parallel GC, if you refer to the one in Hotspot, then I think it's a different GC implementation. There in native image, there's a serial GC, and we have received a contribution from Belsoft. There's a pull request on GitHub that makes some of the phases in the serial GC parallel. And you could argue that this could be a parallel GC, but at this point, it's not in the form where we think this is like living up to our standards. So hopefully, we can merge parallel GC support in the future, but we're still working on this essentially. So yeah, there's no update in the JDK 22 release. Maybe we'll have an update for 23.
Mm-hmm. Yeah, feel free to ask us if you have any more questions.
Okay, more. Yes, another thing that we're now providing is a flag throw missing registration errors, and you can put this as a build argument in your native image build, and then native image, instead of silently doing what reflection would be doing, for example, returning null, and would throw dedicated exceptions that can help you understand where you're missing metadata, and it will also show you what kind of metadata you need to add. So, for example, you do class for name, and then there is some property value or so that has been read, so the compiler can't, or the analysis can't automatically resolve the reflection. Then class for name would return null, right? And some libraries and frameworks, they have fallback code. If the value is none, then it can't find whatever it wants to call reflectively, and then it moves on. And today you wouldn't be noticing this. You would just run in the fallback code. In some cases, you can't really tell what's going on. But if you use this flag, you can say, for these packages, I actually want to be informed if there's a registration missing, if a class for name, for example, is called, and then you get a dedicated exception. And when the exception throws, of course, you can catch it. But also, if it throws all the way to the user and you get the stack trace, then it will tell you exactly what registration was missing, so that you can go and fix your metadata and improve your executable.
Right.
Okay, you want to take the next one?
Yeah, and just a few smaller things. So we also added support for even more GFR events. So we have a nice ongoing collaboration with Red Hat to extend further and further GFR event support in GraalVM, and this is growing bigger in every GraalVM release.
Yeah, big shout out to Robert. He's been working on JFR a lot, and the contributions are great. So please,
yes, thank you, Robert.
Keep them coming, and this is great work. Yeah.
Yes, true. And now we also have a nice API option for thread dumping as well. So you can use enable monitoring equals thread dump for that now.
Yep.
Yes, and we also improved the mechanism for tracking agent calls. So the agent now tracks calls to the following items, such as class loader, find system class, etc. So more calls are now available to the agent. And in terms of things that you can try yourself, we also published a very nice step-by-step demo. So if you want to build specifically small container images with GraalVM, you see a lot of interest in this and you get a lot of questions, what are some good tips and tricks and good practices, you can go ahead and try out this demo and get your image size in a container to as low as 5 megabytes, I think it was. So yeah,
1.5.
yes,
1.5.
1.5. So it's a very good
Yeah.
demo. Go ahead and give it a try if you want to build smaller images with GraalVM.
If you want to go all in, you build a static executable which has zero dependencies, and then you stick that into a Scratch container, which is exactly what Sean has done. And that's
Yes,
how you can get your container size to insanely small numbers.
exactly. Okay, and we are getting another question, and that is regarding the AWT support on macOS and Linux.
Yes, so on Linux, AWT is already working, and with that I
Mhm.
mean it is AWT libraries are actually dynamically linked. So if you're compiling an application that makes use of AWT and or Swing, which is built on top of it, then you end up not just with a native executable, but also with the lib AWT libraries and dependencies. So you get the identical behavior that you would get on Hotspot. So for that, you still need to provide metadata. So I'm guessing Suraj is referring to out of the box experience for AWT. Before we can provide this, I think we certainly still need to address the macOS issue. On Windows and Linux, we are dynamically linking AWT libraries already, and that works with metadata. On macOS, we don't. So builds fail because AWT isn't really designed to be statically linked, at least anymore. So we still need to switch to dynamic linking on macOS. That is still pending. And once that is done, I think it would be really cool if someone in the community could help us generate metadata for AWT. And maybe we can add this to the reachability metadata repository where metadata can be shared. I'm not sure we can ship it with the GraalVM JDK because it's AWT is a real beast, and maintaining it is really hard too. So maybe this is something that we can pull off together as a community.
Thanks. And that has been all for native image so far. And want to talk about the compiler updates as well. So the biggest thing for us is that we are working towards Project Galahad. And Project Galahad is this effort to incorporate GraalVM into OpenJDK. So there has been some work done in that direction. And as a part of that, our options for the compiler are now using the new JDK Graal prefix. And in other compiler news, we wanted to feature this very nice performance report done by Iana and Florin when they did measurements of JET compilers that are available on the JVM. So I believe that was Oracle, GraalVM, yes, OpenJDK and GraalVM Community Edition. And they did a lot of benchmarks. I believe it was in the end like an average of like almost 1,000 benchmarks or something, so a really good amount. And the observations show that GraalJet can run applications faster, around 17% on ARM, and then up to 23% faster on x64. So that's very cool. And there's an easy way for you to make your applications faster just by moving to GraalJet. If you are not ready to
Optimize.
use native image, or if you have some, steps to take to use native image, GraalJet can be an easy win in terms of performance for your applications.
Yeah, that was not the blog post that says optimization zero. Use the GraalJIT, right? That was the
Yeah,
other blog post, right?
yeah, yeah,
Yeah.
yeah, yeah.
Yeah, so just use the Graal JDK as a drop-in, as you put this as a Java Home SDK, install it or download it somewhere else, and yeah, the Graal JIT is turned on by default. And if you're using Oracle GraalVM, you should see some nice improvements without doing any extra work.
Right. And we want to talk about related projects, so related to GraalVM, related to native image. So one thing is that native build tools, and that is our Maven and Gradle plugin, are now accessing the GraalVM reachability metadata repository by default. So Fabio just mentioned this repo. For a bit more of context, we have created this centralized place on GitHub for those libraries, tools, etc., that do not yet provide configuration for native image within the library itself. So the next best thing that we can offer is the centralized place where people can contribute and then share and reuse configuration that is needed for native image. And by default, this makes that those libraries work with native image. So
Can you click on this link, this web page in the README in the second paragraph? That's actually taking you to the
yeah,
GraalVM
all
website.
yeah.
So if you're a user of this, you may want to check out this page. But if you want to help the ecosystem around native image grow, then yeah, the repository is where you can open pull requests or open tickets. But this list here on our website tells you like what libraries, gives you an overview of what libraries are already testing with native image and provide metadata out of the box, right? So if there's one star on the right, then that means there's metadata in the metadata repository essentially. And if there's 2 stars, which is the even better level, then the library is providing metadata within their jars. So that means, yeah, you get the full out of the box experience. So maybe your dependency is already in here. You just need to update your dependency. Or if your library is not in here, maybe talk to your library or framework author and ask them to provide support for native image. And when they do, they can also be part of this list if they want.
It's a very long list.
Yeah, I'm surprised. It keeps growing and it's pretty long. Yeah.
Yeah. So one thing that I want to say here is that now that native build tools enable access to the repo by default, if you want to move your existing application to native image, as a first step, what I would have done is let's say I'm using Maven, so I would add this to my POM.xml, or rather not this, right, because this is for the repo, but I would add native build tools to my project as a dependency, and then this means that all those libraries and configuration for them will be discovered for me automatically, right? I don't need to figure out configuration for each library. If I'm using Maven or Gradle plugin from native build tools, they will go and they will pull, they will look at my project, so which dependencies I'm using, and then pull the config for those libraries so they are compatible with native image. That's pretty cool. And this is now on by default if you're using native build tools.
Yeah, I just made a note that we need to update those boxes on the top because
Yes.
that is precisely what we have changed, right? So this is turned on
Yeah.
by
I just
default
noticed as
now.
well as I was
Yeah.
speaking about it. Yeah.
Yeah. Okay, there's another
Yeah.
question. No, you don't need to. The reachability metadata is actually shipped as part of the native build tool. So the moment you pull the native build tools, you should also have a copy of the reachability metadata in there.
Yep. Okay, let's go back and see what else is new. And yeah, as always, we keep working on our tooling. So for example, native build tools had a new release that is 0.10.1. So upgrade if you haven't had a chance yet. And then we will talk about community and ecosystem updates. And we have about, not that many minutes left, 8 minutes left. So if you have any questions, the next maybe 5 minutes would be the time to ask them. But let's talk about what's new in the community. So we had this blog post talking about how Oracle NetSuite moved to GraalVM JDK. So not to native image, but to GraalVM JDK with GraalVM JIT. And they did so to improve performance and also reduce resources usage even on JIT. And the next item is about our GitHub actions and how many repos are using the GitHub actions for GraalVM. How cool is that? So we see over 2,000 repos relying on the GraalVM GitHub action. Okay, and I see the comment that it's great that metadata is now the part of build tools. Yeah, I think so as well. Now, in other community updates, so Julian sharing that the JHipster Lite project generator is running on native image and on the latest build, and it uses only a fraction of memory, so it can run on a very small cloud instance in production and serve all those requests coming in. And continuing our AI chatbots theme, there is also a very nice example of the Spring AI embedding where you can try and build such an apps very easily yourself, and that will be running on GraalVM and native image specifically. We talked about LangChain4j and we showed a demo. And there is also a nice article from the Tornado VM team talking about how you can run polyglot applications even faster by leveraging the GPUs on your machine. And one more cool update is that you might know about MLE, that is the multilingual engine in Oracle database that lets you execute JavaScript right in your database. And we saw a lot of interest in that project. So now a similar functionality is available in MySQL as well, where GraalVM is also embedded and can do the same thing. So execute GraalVM languages, in this example, JavaScript within your database itself. And we see some more cool examples of apps running faster and smaller with GraalVM. And I like this sample. So this is a new library called Native Type Map, and it has been developed native image friendly from the start. So it's nice to see this adoption in the community and people developing applications and libraries kind of being aware of GraalVM native image and being friendly toward from the very beginning. That is very cool. And that was it for this release blog post. And as Fabio mentioned, we have another one where we talk about updates in Truffle and in Graal languages. So you can find both blog posts at medium.com GraalVM. And I want to show you once again our website and where you can get GraalVM from. So it has been updated to JDK 22. As you can see, you can already learn everything there is to know about it, thanks to our awesome website team who already rolled out the updates. And you can download and find all the instructions here.
Yeah, and I just checked; it's not an SDK man yet, but that should be fixed within the next 24 hours. I think.
Yeah, I
they
think by
update
tomorrow morning
once
you
a
can
day.
expect both Java and GraalVM builds, right?
Yes, but you can just download from the website. There's a direct download link. Use it in the GitHub Actions. I'm sure it will soon be available, or maybe it's already automatically available through the Buildpack support. And go download it. Give this a try. Let us know about experimental features, especially about experimental features. What you like about them, what you don't like about them, and tell us what you'd like to see next in GraalVM, so that we can make good decisions for everyone, right? And help you get the most out of GraalVM.
Yes. Seems like I was about to say that there are no more questions, and one more question popped up. Let's look at that. What can you say about the performance of Graal native, Crack, or Project Laden? That's a good question. I think we are getting similar questions almost every release stream. So talking about performance, I want to address GraalVM, Native Image, and Project Crack. So it's nice to see more such projects popping up in the community. It seems like we are addressing a real challenge in the community. For example, addressing the Java's cold start issues for bigger applications. So it's nice to see more applications, like more projects like that. When it comes to Project Crack, I think there is one big distinction between Native Image and Project Crack, and that is that Project Crack gives you faster startup time. But we talked about Native Image and its benefits, and there are way more to it than just the startup time, right? You are saving your memory, you're using fewer resources, you get additional security benefits from using Native Image. So it's not just that, it's more than just startup time, right?
Yeah,
And
well,
yeah.
Oh, sorry.
No, I just want to say the Project Lighten is being actively developed. We are tracking it. We are following the updates. So let's see.
Yeah, well, the question was particularly about performance. So, well, on Crack, you eventually just get the same performance that you get on Hotspot, right? You get better startup times. That's the whole purpose of Crack, but that requires an additional file, and it also comes with like the essentially like a snapshot of what's been initialized, and that comes with the same issues that you can also get if you're using native wrong, right? Like persisting passwords or something that you really don't want, right? So in a way, Crack doesn't really address performance. You just get the same performance on Hotspot. And with Graal Native, you can sometimes be better, right? You don't always need to be faster, but maybe you can make better use of what's available on your machine, right? And I think the 1 billion row challenge demonstrated that nicely. If you remember, like you can do the same work well, you can do the same job with less work, right? Native only needed something in the 17 CPU cycles, whereas Hotspot just needs more, right? And there's really not much that you can do about this with Crack, for example, right? And yeah, and with Project Layden, I think it's very yeah, still like exploring the space, what's going on, and defining what will be possible in the JDK project in the future, or the yeah, and maybe one day native image could become one of those condensers, but it's like really hard to say at this point, right? So we can only speculate.
Yes, I think we are out of questions and we are almost out of time. Two more things that I want to mention. So, as you know, in 1 minute, there will be the Java 22 launch stream. So, going and join that one, we will join it as well. And we will also be back to talk to you at, I think, 8:45 Central European time in the Java stream. So, you will get a quick update on GraalVM. So, if you want to see more of us and hear more of GraalVM, tune in for the Java stream at 8:45. And also we have more more updates for you on the GraalVM website, so just go there and get the new builds. With that, I think that's all, Fabio, right?
Yes, that's it for today. Thanks
Yeah.
all for participating, for making this fun, and yeah, we hope you learned something about the new release, and can't wait to test it out yourself.
And we hope you're excited for the release. So yeah, let us know how you like it. Talk to us. We are looking forward to hearing your feedback. And also, we've been told that there are way more fun and educational videos that you can find on the GraalVM channel. So hopefully we will add those somewhere here. So yeah, check out the GraalVM channel for more content about GraalVM. Thank you all for joining, and see you next time, or see you in the Java stream. Bye.
Bye bye.